Okay, so welcome back. This time out, we're going to be looking at metadata, and metadata is going to be crucial for most applications because it's what's going to allow us to filter our vector stores uh, based on some criteria. So, for example, maybe we only want to look at the chunks that have been generated in our vector store in the last few weeks. And so if we attach time information to each of these text chunks, then we're going to be able to filter that out. So that's the essential idea. Let's zoom into the notebook and you'll see that this time we're going to be, let's have a little bit closer. This time we're going to be using LangChain. So if you see the link in the comments below, you'll see a link to the LangChain series where I go through the basics of LangChain. It's got its own syntax. So the only reason I'm doing that is because it's got its own syntax. And if you don't understand what's going on with this syntax, then it can be a little bit confusing. But once you understand, then LangChain is just as easy to understand as anything else. So check out that video if you want to get those videos, if you want to get the basics of LangChain. Personally, I find it easier to work in LangChain than with Llama Index. It's a little bit more verbose, and there is a little bit more documentation and assistance out there should something go wrong. So we're going to be installing all of our LangChain libraries. This Chroma DB, that's going to be our vector store. We're going to be using this sentence transformers to get some models, and this time we're going to be working on some data set that we're going to pull from this data sets library. Now we're going to be relying on some pandas here, and the reason we're relying on pandas is because it's a very nice format to enable us to specify what metadata we want to include in these text chunks. So we're just here importing some other stuff that we might need, but let's not worry too much about that. You can check out the notebook in your own time, and let's have a look at this data set that we are downloading. We can see it's some tickets data, it's some IT ticket system, and it's got a number of different fields, and we're going to just load that into a pandas data frame. And so let's have a look at this data frame. What does it look like? Well, we've got some category, some user problem, and some response. And that was what was in the initial data set. These extra columns you see here, it's just because I've already run the cells in this, and I create, in fact, with this code here, I create some fictitious resolved column to see whether the ticket has been resolved or not, and some sort of days, which is it's gonna be what we're gonna filter by to do a simulation of filtering by time. So that's the data that we're working with, and it's going to enable us to have some sort of examples. And I think, yeah, just in relation to this data, then what I've got is these categories as well. I've got these different categories, and I just filtered out some of the categories. But the end result is we end up with some data with about 260 rows and these five different columns. So we got some data. It's in a pandas data frame, and you can see we're using this data frame loader. Now, whatever format your data is in LangChain or Llama Index, there's going to be some data loader which is going to enable you to get from that format to, if you're in Llama Index, some text nodes, or if you're in LangChain, you'll see that those are called, in fact, documents. But I'll just go through this data loader. What does it require? It requires a data frame and it requires which column in the data frame you are going to use to create the embeddings. And so we specify that, and all of the other columns in the data frame are going to be loaded onto those documents as metadata. So we can see here we've got 263 rows, but now that's converted into a list, and each element of that list is of type LangChain document. And it's a little bit confusing to use this terminology document, because if I think of document, I'm thinking of the whole big document, and here it's referring to one tiny split of that as a document. So LangChain calls them documents, Llama Index calls them text nodes. I think I prefer to call them chunks of text. It's a little bit more intuitive. And so the page content is the text that we use for the embedding. And apart from this text that we use for the embedding, we've got all our other metadata from the different columns of our pandas data frame. So it's a very effective way to be able to load up metadata with these text nodes. There are of course other different methods you can use, but this is just one very convenient way. So the vector store that we're using in this case is going to be a Chroma vector store, but we're going to need to attach, of course, the embedding model to this vector store. And so we're out to Hugging Face, we get a Hugging Face token. This time we're going to use this sentence transformer embeddings to get our model. So we specify a Hugging Face model name here, and we get our embedding model. Now, this vector store here, this is a LangChain wrapper around Chroma. ChromaDB is a Python library that's going to be a vector store for you, and there's a wrapper around it because we're using LangChain. This is going to, I don't know how to say it, LangChainify the Chroma database so that it works with the rest of LangChain very nicely. And so if you're creating one of these things, you're going to need your data, which is your list of LangChain documents. You're going to need your embedding model. You're going to need somewhere to save that database to, because it's been saved locally, and you get some sort of name. I've already got my database, and so I'm just simply going to load it up. I've got the name of where it's coming from, the embedding model we used, and the name of the collection. And so we've got now our vector store. We've got everything saved. Remember that if you're creating this from scratch, you might want to switch from the CPU to the GPU. It's going to be much quicker. And I'm just here creating a function called peak, which takes in this vector store and some ticket ID, and it uses this method here to get this item from the vector store where the ticket ID matches. Okay, so we've created peak. We can have a look just to see if this is operating, and we see, yeah, I want ID number 1. You know, we can specify here whatever ID we want, and just as a little check to make sure that our vector store is up and running. And yeah, here we got ID 20, and we get all the related information. So now we don't have to go to a large language model. We can just simply query that vector store and get back the relevant results. So if I've got some sort of question, I want to convert my string to ID, remember that we actually encoded the query column. I'm going to actually go now and look for other tickets which were similar to this particular query. So we do a similarity search with score, and we define that we want k equals 2 results, and now we should get a list of LangChain documents from our vector store, which has now got this conversion failed when converting from a character. Okay, so we found something which is similar. We can also now access all the metadata for that, and because we're using this similarity search with score, we get this score, which is what is known as cosine distance, which is 1 minus the cosine similarity. So the cosine similarity it's between minus 1 and 1. This basically maps that between 0 and 2, where 0 is the closest similarity. So there you go. We can search this vector store that we've created, and so let's just run this same query now, but let's ask for 4 results, and you'll see we get a list of these 4 results. And this time now, though, let's say we only want Azure SQL categories. We don't want to search the vector store if the category is not Azure SQL. And so we do that by passing into this similarity search this filter, and we filter the database on this category being equal to this value. And when we do that, and I think I need to run this cell in order to refresh these results, then we'll see that everything that was returned now is Azure SQL, so we've filtered by that equivalence. But looking at numeric values, then we just run our standard query just to get a set of results to compare against. So here we can see, let's look at the ID column, and we can see we get 1, 84, 51, and 107. But what we can do with this numeric field is say, okay, yeah, I only want IDs greater than 51. So when I run that, and we have a look at the results, and then we'll see this 51 is not included because it's greater than 51. We get back the 84, the 107, and the next 2 best results. In between 2 values, similar here, we filter. You do need to pass in a dictionary. There's a special format to that, so I'll let you check that out either in the documents or just by looking at this notebook in slow time. But here we're saying we want the ID to be greater than 110 and the ID to be less than or equal to 135. So we can specify between 2 values, and of course, if we run this cell first, we should get back the correct results between 110 and 135. And so the last thing we did, I think, was the date. So we can, of course, the date is a numeric field, and here we've got all sorts of date, and we have got some things that have been resolved and some things that haven't been resolved. So now I think if we go to this example here, and this example is saying I want 2 things. I want it to be resolved equal to false, so I want only the tickets that haven't been resolved, and I only want things in the last 3 weeks. And when we do that, we get back our results, and there you go. Only things that are false for resolved, and the date is less than 3 weeks ago. So there you go. That's a little look at how we can load in metadata, and how we can filter our vector store by this metadata. So I'll see you guys in the next video.